was able to successfully get one part soldered, and well, we had the diodes that I unsuccessfully soldered, but successfully desoldered the ones that I was able to solder. But through the magic of, hey, wait, is that a squirrel over there? Ah, look at that. I have more components soldered on a different board. Ha ha ha. Actually, I went to go order the parts I had borrowed from myself because I had 2 sets of PCBs. I had the one I initially bought. Fragilities! Thank you for the follow. I have 2 PCBs because I had the one I bought from Adafruit when I found the project and bought a set of PCBs, and then I had a set from where I bought some parts on eBay, and it just happened to have a set of parts. When I flowed the FTDI chip on this board, it didn't go right, and I ended up having to borrow parts from my build to debug the FTDI chip and make sure it was working. And so, on Monday, when I realized I'd borrowed parts from my build, because I was actually going to sell the second set of boards with a reflowed chip, well, I realized that some of the components I ordered have been discontinued. And some of the other parts that I ordered have stupidly long lead times. So therefore, I decided to give up on the idea of selling this board set. I'll probably end up selling the other board set, which does have an FTDI chip on it. Hey, it's got a power jack on it. The other board's clean. But I realized I wasn't going to be able to order some of these parts. I mean, I could have found equivalents, but, well, I had actually purposely ordered Nichicon audio capacitors for my Zocks box build, and I wasn't going to be able to order them. So, anyways, therefore, you will notice I am going to continue the build on a different set of PCBs. The reason why the components I have soldered to this are the ones necessary to power the FTDI chip, because the FTDI chip is not powered on this circuit. It is not powered by the USB port. It is powered by the 5-volt rail on the Zocks box. So in order to test if the chip was working, I had to look at the schematic, and I had to solder enough together so that I had a 5-volt rail. There's the 5-volt linear regulator, as well as the minimum chips the FTDI chip requires for USB communications. So there's some of the filter caps, some of the resistors that are on between various pins on the USB connector for however USB does its signaling, and then the circuitry for the resonator that the FTDI chip uses. So that is why I have seemingly surprisingly gone with components on this board. Therefore, as I go through these instructions that I have to my left to solder the project, I will be skipping some of the steps because I did them at this point. It was probably 2 years ago. Also, if you realize what a miserable time I was having soldering on Monday, well, I soldered these. I can solder. I just was having technical problems with either the solder I was trying to use or the tips I was trying to use. And I asked one of my coworkers who solders a lot more than I do, and he gave me a couple pointers, which I'm not going to try to go through on stream because I don't necessarily have everything I need to do. But they basically boiled down to the tips I was trying to use, because they're clone tips. they may have a higher thermal resistance than ideal, so they may not be putting down as much heat as they should be. I don't think they're oxidized, so that's probably not it. And it's also possible that the components I was trying to use are contaminated, which if that's the case, then I probably will have trouble with the leaded solder I'm going to use on this board, because I started assembling this with leaded solder. And quite honestly, as valuable as this board will become with parts on it, and the further I get, the less I want to damage the board, I'm going to go with leaded solder because, well, I'm sure I could go wrong with it without trying hard, but hopefully I won't. So, I have my rework station is actually inconveniently located because it will not fit on my desk. So as long as I don't accidentally turn on the hot air gun, we're fine. I am just trying to move some things out of my way that I don't need. So tonight I am going to use my Blackjack Solderworks rework station. I have a conical tip. It's actually, I only have 2 tips for this soldering iron, but this one should be fine. This is comparable. I bought this because it's comparable to one that Bruce at Brankus Creations recommends. He seems to be quite knowledgeable about soldering, so I thought I'd give this tip a try. It is almost, if not the size of the Hacko tip he uses in his soldering iron. I have my trusty tip tinner, which I have tinned the tip. It looks pretty good right now, so I don't need to start off soldering it. I have some 6337 no clean rosin core flux solder. I suspect this solder will be just fine, because quite honestly, MG Chemicals is a reputable company. It's got all sorts of danger warnings on the side of it. I have a water bottle downstairs in case I need it, but it is well far away from my solder station because leaded solder. I will be using some Chip Quick Flux. Because I like to use, well, for this flux here, this bottled flux, since you don't actually apply the tip to whatever you're trying to apply flux to, well, I'll use it for any soldering. I just hadn't opened it yet. But for using a flux pin, I usually like to use a separate flux pin for leaded and lead-free, so if I manage to contaminate the pin, well, I don't spread contaminants between my soldering irons. And that would probably be, and I guess to some extent, just in case I solder something with lead-free solder where I just really don't want to get leaded solder on something I'm soldering lead-free, because I will try lead-free soldering again, just not tonight. I've had 2 fails this week with the lead-free solder I was trying to use. I'm going to save myself the grief of a 3rd night, because I would like to actually just solder and successfully solder and not flail around. I felt really bad Monday after trying to solder it. I'm also realized I forgot to open up my window to YouTube on my other monitor, so if you'll bear with me one moment. because I'm not convinced that the chat in front of me will actually show the YouTube chat should anyone pop in there. So if you are watching on YouTube, it would be cool if you'd say hi so that I could see if it actually shows up in the OBS chat or if it's only going to show up in the YouTube window. I know the Twitch chat works. So, but anyways, so I got my flux pen, I got my flux dispenser, leaded solder, my soldering iron, and got the components in front of me. And last but not least, safety glasses. And if anyone's concerned about the fact that if you follow me on Twitch or you subscribe on YouTube and you're afraid I'm not going to see your or hear the alert because I don't have my headphones on, fear not. As Fragility's proved, I have the sound coming through the TV that's beside me, which is hopefully far enough away that it won't cause an echo on the audio. But I keep running over my headphone cord with the little stool I'm sitting on, and I'm sure that's not good for it. So I'm going to try this tonight. Plus, also, I hope you'll forgive me, but I don't want the audio blaring through my headphones to sideline me at an inopportune point while soldering. I know. I mean, after all, I have a hot soldering iron in my hand. All right, now I do need to make one adjustment. And for that, I need to ask Siri a question. And so I don't accidentally activate your Siri if you use Siri. I'll kindly
650 degrees Fahrenheit is 343.3 degrees Celsius.
Excellent. All right. All right. I just needed to adjust my reflow station. I know that 650 degrees Fahrenheit is a good starting point for leaded solder. The reflow station I am using does not let you change between Fahrenheit and Celsius. So, as you heard, Siri gave me a hand with that. So, I have set the station to 350 degrees. That should be close enough for government work. And if it will be close enough to 350 degrees that I'm not going to worry about it. What has me a little more concerned is the temperature variation of the soldering iron as shown on the display of my rework station. That has me a bit more concerned. I'm just hoping that's a glitch of something and not the fact that it's actually reaching 483 degrees. Because that would be 483 degrees Celsius, and that would be exceedingly hot for even lead-free solder. All right. So, we left off with me trying to solder the bridge rectifier diodes on the first board, but I've now gone to this board, which already has the bridge rectifier diodes installed, and I've already tested them. Oh, so let's see here. The next would be the 2200 microfarad capacitors. Those are already attached. So let's see here. Clip the long leads. Try measuring AC voltage. Okay, I know those are working. Place the regulator. All right. Well, I've already, regulators attached. And let's see here. All right. I've actually So now the next thing we do, because the capacitors and the regulator, the next thing that I have to do that I have not done yet is to place the 7806 6-volt regulator and the two remaining 0.1 microfarad capacitors, C1 and C2. All right, so I already have C1 and C2 attached, so I do not need to do that. But to test the FTDI chip, I did not need the 6-volt rail, so that is the next component we are going to tackle. And by we, of course, I mean the corporate we, because I am unaware that Twitch or YouTube has a technology that will let you reach through your computer monitor and actually assist me. And if they did, I would find that quite disconcerting when an arm reached through my monitor. So if you are an engineer at YouTube or Twitch and you are testing that technology, please, I would prefer that you not reach your hand through my monitor. And of course, the regulator I'm looking for would be the one. Yep. Okay. It was not the one on the bottom, but it was the one right on top of that. All right. So this is a 7806 linear regulator. I guess I bought this from Mauser Electronics, where I bought at least a good portion of the parts for this build. I will let this stay on the screen momentarily so you can see what I purchased. But it is a 6-volt linear regulator, 0.1 amp rating, but we don't need much 6 volts. In fact, no, I don't know what the 6 volts powers the instructions may say, but this component actually looks like a transistor. But it is not. I guess just in case anyone would like to see the chip markings, so there it is. And L78L06 ST Electronics. Oh, that is what the chip looks like. And the other side I don't think has any markings on it. I think there's probably a factory or line code or something. An 18 it looks like. But I guess if anyone was interested in what it looks like, maybe because you've got one or you sourced from somewhere and aren't sure. Well, that is what one that I sourced from a vendor looks like. All right, now I'm going to get my keyboard out of the way. My soldering iron should be up to temperature. All right, so this linear regulator goes okay. Right there, IC21. Yep, that was on the sheet of paper I moved away. All right, so there is on this silk screen, as is usually typical, there is a flat line and a curved line, and the flat edge and the flat line is what lines up. So we just stick the component in. I'm bending the leads out slightly as I push it in, but the nice thing is it should stay in place nicely, just like that. And I'm going to, actually, I'm going to use this to very carefully dispense a little bit of flux. It's probably enough. A little bit will do it. And I'm going to pull my solder out. And I'm going to realize that I do need to turn my little smoke absorber on. So I just have a Blackjack Solderworks smoke absorber. And well, actually, there we go. All right. So that looks like I made a hot mess. What is up? All right, well, that is definitely not good. Well, I will apply some flux. And then I'm going to apply my solder braid. Try to wick that up. Wow, that's... That's a lot of solder I wicked up. All right. Well, I'm going to clip that off and wick some more up. All right, that's better. At least the voltage regulator is no longer shorted. I have ordered a light to help illuminate my workbench. I'm hoping that will be in soon, or rather than later. Now I'm going to examine my solder joints, and, well, quite honestly, they look like they could use a little more flux, or a little more solder. Because it looks like most of the solder I put on just went straight through to the other side of the board the first time. Alright, well, that joint looks better now. And okay, the other two look fine. Alright. Alright, so the 6-volt regulator is those three pins right there, closest to my finger. And it looks decent. Still looks like there's more solder on that one leg than I'd really like, but at least it's not bridged together like it was the first time. All right. So solder and clip parts, measure the voltage across C1. It should be 6 volts. All right. So I have my voltmeter set to voltage. I have the 9-volt power adapter. Plugged in, like so. I am, unfortunately, the cord is really not long enough to, my power adapter cord is not long enough to actually get everything on camera, but it should be, capacitor C1 should have 6 volts across it, and I'm going to measure from the underside of the board. C1 is going to be, I think that, right, this capacitor right here. Oh, all right. And no. No, it does not appear as if we have the correct voltage. Let me try from the top side where there's, just in case it's flux. The flux is preventing me from seeing what I'm expecting. .5 volts. Well, that is not correct. Okay. So we do not have the correct voltage. So I guess I need to check the solder joints. Maybe they are not. Maybe they're not good. Oh. A soldering iron went to sleep. All right. Looks like it, at least if I'm reading the display correctly, it is back up to temperature. So I'm going to hit these again, thinking maybe the solder joints are not good. Well, that doesn't look right. Alright, so I've soldered it again. I don't like the way the solder is kind of doing that. That just looks awful. But it's not bridged. I don't know. The joints, I was expecting them to look shinier. So it should be those 3 joints there. And well, I don't like the look of that. I'm hoping that's just burnt flux. Well, there's one thing I can do. Got a bottle of isopropyl alcohol, and I have no longer a toothbrush. And actually, the secret is I just bought some cheap toothbrushes at the grocery store, and that's what I use for like the soft toothbrushes, and that's what I'm using. Just trying to kind of try to clean the flux away so I can get a look under the microscope again and see what's going on with these solder joints. So we'll bring out my pluggable cam again. Now, looks like I might have scorched the solder mask, but if I did, it's not in a place that should have a trace, and the flux was making it look like I'd broken one of these traces was broken, but they look it's not the best looking solder joint. don't know why the solder is doing that either. Maybe the... Well, maybe my soldering iron's too hot for this solder? There's such a thing? I forgot to look up the data sheet for this solder. That doesn't say on the package. All right, well. All right, well, let's pull up the see if we can't find the data sheet. So, all right, let's see, MG Chemicals, that looks like their website. Products. Would say this is a solder wire. And this would be SN63 PB37 no clean solder wire. That does appear to be the formulation. Catalog 486018G. Yes, confirmed. That is what I have. And let's see, I think I need the Canada US version because that should match what I have. General flux parameters. Not what I'm looking for. Flux core properties. I'm looking to see if they have a recommended soldering iron temperature. So the melting point is 361 degrees Fahrenheit. Do not exceed 260 degrees C, 500 degrees F. Oh. Well, that might explain my horrible experience. As I had it at 350, and it said don't go above 260. So if my math is correct, I was 90 degrees C off. I have no idea what that is in the units that we use here in the US is, but I dare say that's a lot. So maybe the problem is these solder joints are poor because the iron was set too high. Well, I'm going to clean up my blobby solder here. And I'm not horribly concerned about this linear regulator because it is, I believe it was a roast compliant one, so it should be capable of handling a lot more heat than I'm giving it. Alright, and I'm going to clean up the Alright. And now I am going to try see if I can't get a nice looking solder joint on all three of these legs now. Alright, I don't know. Alright. Maybe the pins on this linear regulator are smaller than the drill holes. Alright, I guess the only thing there's left to do is to see if, because it doesn't look like it's shorting, it's just I don't like the way it looks on the top side. But it doesn't appear to be shorted, so plug power in. I'm going to find my voltmeter. Well, Okay, so I got 11 volts AC, but well, it appears as if there's something wrong with it appears as if there's something wrong with the linear regulator. So I guess I want to desolder it and then check the traces. Make sure there's not a short on the board or something. Just have to wait for my desolder gun to heat up. Well, it would be interesting to know what the lead time is on that part. Whoa. Well, that wasn't good. Okay, I dare say that desolder guns are not supposed to do that. Therefore, I am not going to trust that. I'm not even going to trust the soldering iron anymore now. Well, I'm going. Well. Well, I guess I can trust the soldering iron. I'm going to unplug the desoldering gun though. All right. Yes, we're. I. Well, you know, to be fair, I don't know if that spark was because the desoldering gun's defective, or if maybe I discharged the caps. Although I've been having trouble with that desoldering gun, so it could be a all of the above answer. Well, I almost have it out. The hole on the left looks clean. The hole on the right looks clean. The one on the middle looks like there's still some solder in it. So all right. I hope the part will hopefully just. I'm hoping it will now just come out. Looks like there's still some solder holding it on the top side on the one pin, so I'm going to do this probably will get me in trouble. Move. Well, and then let's see if I can't get the solder cleaned up on this side of the board. All right. That's much better. All right, so I am going to see if I can't do or check the continuity. Tweak that a little bit. Okay, so I believe if I'm looking at the traces right, and I guess since I'm not soldering, I'll do that, and so I can see things a little better. I believe, actually, I think the traces are on the underside. So here's capacitor 1 that was supposed to show 6 volts. And it looks like there is a trace between here and here. Which does appear to be correct. And it looks like there's also a trace between here and here. Appears to be correct. And the third leg, there's a trace between here and here. Which I presume is also correct. And I'll trace back where that goes. I know my hand's in front of it, but yeah. Okay, so the 3 traces are fine. So that linear regulator, I believe the middle pin is, looks like it's coming from, okay, it's coming from one of the pins on the 5-volt linear regulator. See, yeah, one of the pins on the 5-volt regulator is going to the middle pin of that voltage regulator. The other pin is going to probably ground. And then the third one is going to J5, which I believe is a jumper. Actually, it probably helped to pull the schematic open. Download. That's the schematic for the I/O board. Oops. Oh, which was on SourceForge. Okay, I will have to go. I think there's a repository somewhere. Oh, here we go. Okay, the power supply. So there's how the power supply works on the Zocks box. And of course, this all would probably be easier to figure out what 78. So the linear regulator help. I think in reality, I suspect maybe I baked the component trying to solder it. So I guess in essence, it doesn't really matter what the pins are. I'm just going to instead come over to the instructions and look for the instructions after the linear regulator is soldered. And you insert the power plug and measure the DC voltage from the metal back to 7805 and the leftmost pin as shown. Basically, I want to make sure that that I did not damage anything. So if I'm reading that right, and I actually come back to voltage mode. So if so this is the 5-volt regulator. The back is ground, and the leftmost pin is well, it would appear. Okay, so my AC transformer is still measuring 11 volts. All right, I'm gonna do these tests one by one because it would appear as if I may have shorted something on the board. All right, so AC should be above 10 volts, given what's on it. So then after the diodes and the capacitors, the test was to measure AC voltage across C3 and C5. So those are these two. Or well, that's not right. And okay, so how do I? Okay, well, something is, well, it would appear as if I maybe did some real damage when I touched something with the desoldering gun. As it would appear as if my 5-volt regulator is not outputting 5 volts. These capacitors don't have anywhere near the correct voltage on them, because the directions say that there should be, or the auto ranging function of my meter is well, actually, you know, those capacitors bled down to 0, so maybe I didn't dump current from those capacitors, because it looks like when you unplug the adapter, the linear regulator basically works to bleed off the voltage from them. So I'm kind of inclined to say that my desoldering gun did dump voltage into the board. All right. I believe I'm going to go by my usual adage of if you start causing damage, stop. So I'm going to take a break. I'm going to try to figure out what to do next. I'm going yeah, and I'm going to wash my hands so I can get a drink of water because I've been, well, using lead solder. So anyways, I'm going to take a break. I'll figure out what to do. Probably clean up my workbench. And didn't mean to click on something that I haven't defined yet. Anyways, so stay tuned. I'll be back in, well, hopefully in about 6 minutes or so, maybe a little longer, because I'm going to collect my thoughts and set some things aside so that I can go, because I may be ordering parts on Friday. So I'll be right back. All right. I'm back. And I'm going to try going back to this board, which means I'm going to try going back to this solder. And that's only because, well, long story, my preference. Maybe it doesn't matter, but I have a soldering iron for lead solder work and a soldering iron for lead-free solder work. And I would like to keep it that way. My preference. Maybe there is something to it. Maybe it doesn't really matter. But the rework station that has disappointed me for the last time that rework station has disappointed me for the last time. Now, there's a thought. Maybe it would be more appropriate and less likely to damage things. Maybe let's take it apart. Or at least open it up. See if there's anything visibly wrong with it. Because maybe there is something that can be fixed wrong with it. Because I pretty much convinced myself it dumped current into that board. Because I think I demonstrated to myself that those bulk capacitors would have discharged due to the linear regulator. So, let me go. It's just over here to the side. I put it in a place where it really couldn't cause any harm. Let me take a moment to attach the attachable items. Oh, this could be a really interesting disassembly. It looks like I'm going to actually have to swap lenses or you're not going to be able to see anything. Oh, please. I'll be right back to All right, there we go. I think that will give you a about as good of a view as it's going to get to the rework station of weeping and gnashing of teeth. All right, so let's see how this thing ticks and see if there's anything visibly wrong with it that might explain its behavior. And if we don't see anything wrong with it, then I'll maybe see if I can't figure out a way to check maybe the desoldering gun itself is to blame. But the thing is, if only one of the devices on this were causing trouble with the temperature being displaying wildly erratically, I would be more inclined to say I have a bad temperature probe in one of them. But the thing is, the desolder gun and the soldering iron both have wildly fluctuating temperatures on the display. And the thing is that soldering iron, the tip is brand new. The sensor is in the tip. I may bring it over next. So I would be inclined to believe that if I had only one that was acting erratically, it was for sure that. But I haven't used the air gun. But with both of them acting erratically, that more leads me to believe that there might actually be something up in maybe the board that reads the temperature. Maybe I'm wrong, but maybe opening it and seeing the control board might maybe reveal, do they have one thermocouple? Because it's probably using thermocouples, but it will tell me if there's one or multiple thermocouple sensors. Because if there's only one sensor, then the sensor could be bad. And so it's multiplexing it. But if there's more than one sensor, then I don't know, maybe something else. And, well, I immediately get to the board, and there are lots and lots of wires holding it in. But there we go. At least I got the top of the case off. And as you can see, when doing something like this, always unplug it. And still be careful of power supply boards. So here's the power supply board. Actually, it's an interesting design. So there is a fuse on the AC input, or at least there's a space for one. I presume there's a fuse in it, because that would be pretty weird to have a cord holder that has a fuse. Yeah. Oh, and there's even a spare fuse in it. Okay. That's good. But there's also a fuse internal on the... okay. So the external fuse is a 3-amp fuse, according to the legend. But internally, there's a 5-amp fuse. I guess that doesn't surprise me that there's two fuses. So there's internal protection. I do see on this board that round mark on the side of that doesn't looks kind of bad, but it looks like it doesn't look, well, it looks burned, but yet it doesn't look burned. That's weird. I don't know if you can see this mark here. It looks burned, but it doesn't look burned, if that makes any sense. All right, so I am looking at where the probes connect internally, and I already see something that doesn't look good. In fact, I think I see why this unit was probably returned, because I bought this refurbished, and I think I see why the first customer returned it. I'm trying to see if I can't get a better view for you because of where it is. I'm hoping that this camera will, well, I can at least use this as a light to start to show you where I see something that looks pretty bad. But if you notice on the front, so there are two, I guess they call them like airplane style connectors. I don't know what the actual term is, but I see airplane style connectors online when I look for them. But this one here that I'm trying to point at is where the soldering iron goes in. And then this one here is where the desolder gun goes in. And you might be able to tell there. I know it's kind of hard. And maybe I should let me lower this table camera, and then I think you might be able to see it just a little bit better. Because I think I'm not going to switch lenses on you again. At least not for this. All right. And let me illuminate. And let me see if I can't tweak the focus just a little bit. Okay. So if you look at on the left, all of the wires going to the soldering iron terminal look like they've got a nice heat shrink tubing going. But, and this is where I don't know how far away my pluggable cam can get and still be able to show you what I've. So let me go to, and we'll go to the, okay, I think I went too far one direction. I'm hoping that, yeah, this might actually work. Maybe. Well, it's worth a shot. Otherwise, I'll see if I can't maneuver another camera into place. Or, all right, let me see if I can't focus on this. All right, and then let me see if I can't get the camera into place. I apologize for the. Anyways, this is actually might be confirming what I thought I saw. Anyways, that is the desolder gun connection. And it looks like it's not, the heat shrink tubing looks not, so there's the soldering iron connector. Notice how all the they're all the heat shrink tubing looks nice and neat and proper, and they're all seem to be well situated. And now we come over to the desoldering gun, and the first thing I see is a big blob of solder that is not covered by heat shrink tubing. So already I'm wondering if there's an intermittent connection there, which might explain the, although that doesn't completely explain the why I'm getting erratic behavior on temperature on both, but yeah, that bears further investigation, because that, I mean, there may not be a short there, but now that I look at it under magnification, but that's not quite what I was expecting to see inside of it. All right, so I guess if we go to this power supply board here, and I guess I'll go back to the microscope. So you'll have to bear with me because I'll have to probably focus on everything I point out. But okay, so on the power supply board, here is one of the first things that stuck out at me is this brown goo. And I guess under magnification, it does look like it's brown goo and not the resistor burning itself, I guess, for lack of a better description. I mean, it is a power resistor, 5 watts, 0.5 ohms. So it looks like it's brown goo, and maybe the brown goo has gotten hot, and it wasn't brown when it was initially applied, but it does look like it might actually be some sort of flux or adhesive or something that got on it. So, okay, so that's probably not related to the problem I'm seeing. So here's it looks like probably a MOSFET of some sort. I don't know right offhand, but some sort of power transistor. I mean, it could be a rectifier. Looks like it's got a little bit of solder on it or something. A little shiny part. I don't know what it is. It looks fine. But what I was really interested in is this here. And we might have to go look up the data sheet of it. It looks like I think it looked like a Texas Instruments chip. So it could be a microcontroller of some sort. It might be the thermocouple. It could be the chip that's reading the thermocouple inputs. I mean, it could be both. It could be a microcontroller that can read thermocouples. So it looks like it is and let me turn the light down a little bit to cut down on some of the reflections. Okay, picture won't look as good, but I was having too many reflections trying to read what the chip says. So that chip is I mean, I'm pretty sure that's a Texas Instruments. Okay, I'm going to have to turn the light up and I guess go at a different angle. Oh, there we go. That's a good angle. So it looks like a Texas Instruments 24 ALKLK. It doesn't seem like a Texas Instruments part number. I mean, I could be wrong. LM33. Oh, there we go. I think it's an LM324N. LM324N. Oh, it would help if I had my mouse on the right screen now, wouldn't it? All right. So TI LM 324N. Low power general purpose quad op amp. Okay, well, that's not the chip I thought it was. I mean, quite honestly, the microcontroller for this soldering iron could be on the back side of this PCB and covered in black epoxy, because it could be it could be one of those deals. That's the diode. I'll go back to this camera here once I actually see something that warrants a look. I mean, I see what looks like a couple of bridge rectifiers. It's interesting that there's two. Now that's interesting. Gun RT. Gun ADC. Well, now that's so weird. Okay, let's come back to the microscope. I noticed something else. And this, quite honestly, may be where I've pulled the board out, but so it probably is. This probably isn't it. But anyways, I'll come back to that. There's another chip down here. It's got 6 pins. I really can't see what it is without getting the microscope on it. Sorry for the... When you're working at magnification, it becomes even harder to hold things steady while you're also trying to spin a focus wheel on them. So that is an L1421. MOC 3021. Well, I'm not sure what that is. I guess we can search for that part. Let's see, that's a... Oh, well, that's the same exact part. There's 2 of them. L1421 MOC 3021. I mean, that could be... All right. Okay. Let me see if I can get this board out so we can take a closer look at it. Let me first check to see if I unplug these cables, are they distinct enough that I would be able to plug them back in. Maybe. Well, all right. Well, that was enough to help me see the board. So this PCB is a... Well, it does look like a double-sided board. Through-hole components. I don't see... Actually, I bet the microcontroller's on the front panel board. This is probably just the power board that's in the back. So this board here, I bet it's just the power board. So if we come look at the this board here. So here's our Texas Instruments op amp. And then there's two of these, which I suspect are probably I don't know what they are. I don't know that they're the microcontroller I'm looking for. They're probably power related. There are some diodes. I think that's a power diode. I don't know where I got that idea. I thought I saw the word diode. Oh. No, I did not see the word diode. I saw 600E. And my brain decided to insert a letter to make it a word. Okay. And I suspect some of these are, I mean, there could be some diodes, and some of these are probably MOSFETs, power transistors. I suspect what I'm looking for is on the front panel board. Because now, so this is the connector that I thought was partially unplugged, but I think that may have been just me pulling on the board and partially unplugged it. I think this cable probably comes from the microcontroller. Although it is interesting that there is one of the legends does say iron ADC, but it looks like the iron connector comes back to this board, and then I guess, yeah, that's probably, and then that's how it goes to the front. Although honestly, if the microcontroller's on the front, I don't know why they would have not made the ADC or because that's probably the thermocouple signal. It seems like they would have just maybe run that straight to the front board and not gotten it tied up in the power. Although it should be DC power powering everything. The other interesting, oh, and then there's the gun ADC. So, all right, so it does look like both analog channels do come into this board from the connectors, and I mean, I can see all the wires that I unplugged. So let me see if I can get the front board off. Because it looks like this front cover is held on by a couple screws. It looks like 4 to be exact. Aha. And to be tricky, I didn't use Phillips screws. Looks like it's like an Allen. That's too big. There we go. That one fits. Ah, there we go. Oh. And that's, someone's been in this before. Because one of the front cover screws is not even there. Oh, yep. It's like a Allen key or a hex key. Or I just happened to find something that fits it, whatever it is. All right. Oh, and there's, oh, I'm still caught on something. Oh, I bet I haven't backed that screw out all the way. All right. And for anyone that just happened to join midstream and wonders what in the world I'm doing, well, this soldering iron failed me live on stream. Therefore, it seemed only appropriate that I'm going to see if I can figure out why it failed me live on stream. And I think any rational engineer would do the same thing. Maybe even a few irrational ones. Seems like something Dave Jones at EEV blog might do. At the moment, I'm looking to see if I can figure out what was reading the thermocouples on the devices. Yeah, it feels like someone definitely has been in here before. Or they used a bigger screw here than everywhere else for some strange reason. Although it actually looks like a different screw, almost like someone's been in here and then grabbed the wrong screw off their bench to put it back together, if you know what I mean. Oh, and there's two boards attached to the front. They feel like they're soldered together, so let me remove these other three screws. Ah, okay, well, there's the first manufacturing date. So there are two pumps in here. One is for the desoldering gun, and one is for the air gun. I don't know which pump's which, but there is a QC past sticker on this pump here. It's got a date of 8 December 2016. Oh, there we go. All right. Now that is what I was looking for. That's a big chip. All right, so there we go. There's the front panel electronics. So let's see what we have. I'm going to just give an overview, and then I'll pull out the microscope. So here's the digits. I believe this one on the top, it would be for the air gun. This one is the desolder gun, and this one is the soldering iron. These are the buttons that turn those on and off. Although I think they probably control the MOSFETs on the power board for those three functions, because those buttons do not look like they would handle enough current to do the switching on their own. Let's see, there's a 74HC. So it looks like these are some glue logic chips under here, probably for the displays. Can't see what those two are. Anyways, and then there's this big chip here, which I suspect is the microcontroller. And depending on what we find under this label, which I am ever so carefully going to try to peel off. I found a spudger the other day, but I don't know where I put it. It's one of those labels that isn't going to peel so easily. Oh, fine, be that way, label. You are going to spill your... I mean, I guess this... I mean, it's probably not a ROM chip. It probably is. I mean, there might be a ROM on it, but I think this is the microcontroller. All right, so far, I don't see any manufacturer markings. I was kind of expecting that there would be something under this chip. Then again, maybe it's a... unbranded microcontroller. I mean, I guess it could be unbranded. Maybe this is a... Oh, wait a minute. It's an Atmel. It is an Atmel. Okay. Well, theoretically, you could... I mean, if it's what I think this chip is, you could make custom firmware for it. However, I don't know that I'd want to make custom firmware for a soldering station that dumps current from the desoldering gun into your workpiece. It's an Atmega 16L 8PU 1519D. Atmega 16L. All right, I guess let's see what these other chips are, just or at least what I can see. So this one is looks like a Texas Instruments 74HC595. And then these are, unfortunately, the number's partially obscured. And I don't see... Oh, okay, well, it looks like the first line says China, so maybe the part number is a ULN 2003APG. Assuming that is the word China as in where it was manufactured, although that could be the part number 2. But these do appear to be the same chip here. I mean, since it looks like there's 2 of them, without tracing where traces go, maybe those are the thermocouple. Maybe those are the thermocouple chips I was looking for. But let's pull up the Atmega 16L data sheet. And let's see what that microcontroller can do. Of course, now it's a microchip, but let's see, Atmega 16L. That should be enough to find it. on their website. There we go. Oh, that's the Mauser. Oh, well, that's the 16L8PU. Well, I mean, I think this is the same chip in a different package, but for accuracy, 8PU. Let's give it the full part number. I guess it would be interesting to see how much it costs. Although I was kind of looking for the data sheet. Although that is true. Mauser's website should have a link to the data sheet. So that is a 8-bit microcontroller, which makes sense since it's in the Atmega series. 16K flash, 0.5K EEPROM, 32 I/O pins, 569 single quantity price. Kind of actually, well, I guess this is a higher end station. So I guess I'm not surprised that they would actually spring for a nice microcontroller. So, all right. So this microcontroller has features. A lot of them appear to be very common with the other Atmega series, which doesn't surprise me. Like the up to 16 MIPS. Yep, that's the same for all the Atmegas. All sorts of other stats. Plenty of them. Nice stats. I was kind of curious to see. So peripheral features. I was interested to see if there was anything about. I mean, it has an 8-channel 10-bit ADC. I mean, I'm not a total expert on thermocouples, but the voltage from a thermocouple is in the millivolts, and let's just say this ADC alone would not be enough to measure them, but maybe that's why there's so many op amps on the power board. Maybe they're sending the thermocouple input into an op amp to boost the voltage, and then maybe reading that with from the microcontroller's ADC. I mean, I guess that could be done. Well, so yes, it's a microcontroller with stats. I don't know if that means you could use Arduino, or program it like an Arduino. I mean, I suppose you could write custom firmware for it and get it on it somehow, and it's in a socket. I don't know if that would be necessarily a good idea or a bad idea. It's an idea. I'll leave it at that. You can decide whether you want to take your expensive solder station and load custom firmware on it. But I would want to take a closer look at this desolder gun connector, which just dethreaded it on the inside so I could pull it out and not actually be able to see really anything better. Well, way to go. All right, so this one wire that I had misgivings about it's not shorted to anything. It is certainly weird, though, how all the other wires have the heat shrink nice and neat and all the way down to the connector, and that one, which is a ground wire, or I guess if they're following green as ground, which seems like a good idea to do. I mean, that wire is... I mean, it's soldered, but I don't like the way the heat shrink is. Let me see. All these green wires... Okay, so I think the green is ground. It looks like most of these grounds do tie to the bottom of the case, so that probably is ground. Anyways, this disassembly, well, I don't see anything obviously wrong, but I mean, I guess there's ways chips could go bad and not be able to see anything. I was so hoping to find a blown component or something. Oh, well, that's nice. There's actually 2 fuses on the power supply board. Yeah. I mean, I don't see anything that looks physically damaged. Well, I know the vendor discontinued this model, and maybe they discontinued it because it was, I don't know, disappointing performance. Well, I guess I was certainly disappointed with it. And that concludes my disassembly. If you thought I was going to reassemble it on stream, no. I don't feel like reassembling it now. It has disappointed me that much. It might not get reassembled. Just spoiler alert. Well, at least put all the screws in a bag. Oh. Well, all right. I did just notice something about the flux pen I tried to use. It helps when you read the expiration date. All right, just if you're wondering, I did not recently buy this. So this is not a case of Amazon sent me an old flux pen. This is a case of I just now got to using it. And quite honestly, the pen was working so badly. I have to believe that the expiration, it may actually be expired. Because I couldn't even really tell that any flux was coming out of it. So expired is in, maybe that was a fairly accurate estimate of how long the flux would be fluxy enough to dispense. And with that, I am going to dispense of this off of my workbench. And I'm going to pick up the last few items from the solder station that I dropped and put them with everything else. And yeah, that that concludes my unplanned disassembly. There we go. Now all the parts of the soldering station are together. And I really would always like to go to the end of the scheduled stream time, but quite honestly, given what time it is now, I do not want to start soldering. I'd rather kind of start fresh, almost literally, seeing as the board has 2 components on it, and it is a little warped from my reflow, but I think it's fine. It'll attach into the case, and I think the way it attaches, it's fine that the board's a little warped. So, anyways, I am going to go ahead and call this stream to a rather disappointing end. I do know how to solder. I just wish that my soldering equipment would cooperate, because I really would like to get this synthesizer going. So if you would like to know when I'm streaming next, spoiler alert, I will be streaming tomorrow for the After Yak Mac Attack. Tomorrow night I'm going to put my iMac up on my desk, and we might actually install Tiger on it, and then maybe look at some games that might run well on an iMac G4 that has an 800 megahertz processor. So if you'd like that, running old Mac software on classic Macs, synthesizer builds when the soldering equipment cooperates, other electronics adventures, and even some gaming, then subscribe on YouTube, give me a follow on Twitch. I would like to remind you that if you felt so led, if you are an Amazon Prime customer, one benefit of Amazon Prime is you do get a free Twitch sub. I'm not saying that you have to subscribe to my channel on Twitch. In fact, I would feel totally fine if you told me, hey, I don't want to subscribe to your channel, but I'm glad you told me about that, because I have another content creator that I've really wanted to support, but didn't have $4.99 a month. I was already paying for Prime. I would be totally fine with that too. Just knowing that I helped you know about a benefit that you're already getting with your Amazon Prime subscription. So do check into that. You do have to link your Twitch and your Amazon accounts, but if you're already paying for Prime, you get a free Twitch sub. I think they call it a Prime sub. There are a couple caveats. You do have to manually renew it, but you can renew it with that content creator. So if you have a content creator you've wanted to support but did not want to pay the $4.99, then go link your Amazon account to your Twitch account, which, before you say, well, then Twitch is going to know, Amazon's going to know, and Twitch is going to know, well, Amazon owns Twitch, so Amazon base probably already knows anyways. Linking the 2 accounts might let the 2 parties know a little more, but quite honestly, if you're already ordering from Amazon, they probably already know what games you bought anyways, so it's probably not going to be a big surprise to them if you watch streamers that play that or similar games. Let's just face it. So, but you do have to link the 2 accounts, but then you can, I think you basically would click on the subscribe button on that content creator's page. And if you have not already done so, I believe that's where it will show that you can use your Prime sub. I will warn you though, I think you have to scroll down because the first thing they show you is the paid sub, but then I think the Prime sub shows up under that. You do have to manually renew. You don't have to renew with the same content creator. You can't renew until like day 31 or whatever it is, the like day after. But if you renew that day, or there's a grace period, I don't know what it is. It's still a continuous sub. But caveats you might want to know about the Twitch Prime sub: it is there. If you're paying for Prime, then you've got it. And that reminds me, I do need to go renew my Twitch Prime sub with a content creator. So I guess I'll do that tonight while I'm thinking about it. But I thought I would just share that free thing you get for already paying for Amazon Prime. But other ways you can support the channel. You can, if you're on YouTube, you can like or dislike the video. It will not hurt my feelings if you give this a thumbs down, because I failed to get anything successfully soldered, and in fact seemingly destroyed other parts on the board I was trying to build. I would not feel bad at all if you had to give me a thumbs down for not liking the video. But you do have to give me a thumbs down. Maybe you could leave me some constructive criticism in the comments. Leave me, hey, I saw your video. Maybe you saw something that I didn't notice that was the actual reason I shorted and created sparks. I don't think it was those two big capacitors, because they were discharging from the linear regulator. But maybe I overlooked something. Hey, leave that in the comments. Those help, because if their YouTube uses that for their channel analytics, so that kind of shows them videos that, well, I don't really expect this one to take off that much, but yeah, and honestly, I hope this one's not one that goes viral. Yeah. And if you're on Twitch, you can obviously give me a follow. That way, when I go live on Twitch, which I'm going live on both Twitch and YouTube at the same time. So really, you can pick your favorite service. If you don't have a particular, you can subscribe on YouTube and follow on Twitch. But that way you'll know when I go live, and maybe not every video will be to your forte, but who knows? I do occasionally manage to succeed in doing things. Just not when I pull tools out that I haven't used for a while because of various reasons. But I will eventually get this synthesizer built. Or someone will, even if I have to bequeath this to my grandkids. This thing is going to be built. No, I will eventually figure out my soldering problems. I do know one of the things that could be the problem is these generic Hacko tip. Well, they're not Hacko brand chips. They're generic Hacko clones. It is quite possible that the metal they're made out of is not thermally conductive enough, and that may be why I had so much trouble with my lead-free solder. I did order some tips directly from Hacko. In fact, actually, the ironic thing is one of these tips is a genuine Hacko tip, and I stupidly got them mixed up when I was showing off these tips, because that is how good of a clone these are. And I may have just finally figured out which one is. Well, that doesn't make sense though. Well, maybe that is the Hacko tip. Maybe. Okay. Now it's going to bother me. I'm going to try to figure out which is the Hacko tip. Okay, so I know. So process of elimination. I know which ones are not the genuine Hacko tip because of the shapes of these. So I know these two are not it because they're the wrong shape, and that one's not it, and that one's not it because it's not a chisel tip. That one's not it. That one's not it. That one's definitely not it. It's also not that big, long, pointy one. And it's not that one. So now we are down to 3 tips. Okay, and it's not that one. So here's the problem, because I think the set of clone tips I bought had a tip that was about the same size as the genuine Hacko tip I had. And if I really wanted to, I would go grab a set of calipers and I could measure these, and probably, but I don't remember what model Hacko tip I had. That's the other problem. And on the one hand, I want to say the good thing is I don't remember using the Hacko tip, but yet this tip here looks like it's been heated. But when I look at this tip, I don't know. That's just how bad of that's how good these clones are. I've got them mixed up, and then I had real trouble trying to tell the two apart. So, did I bring a... I'm trying to look to see if I brought some calipers downstairs. Actually, I'm thinking I might have. No. But I don't know that the measurements do me as much good because I don't remember which Hacko tip it is. Because the thing is, if I could figure out which one is the Hacko tip, because these are different sizes, so I think one of these is not going to match the dimensions of a Hacko tip, and one of them will. And if I could figure out which one's which to find the actual Hacko tip, then I might actually be willing to risk trying to solder. How as bad as that sounds. All right, tell you what, I guess now I'm really curious. I want to figure out which is which for sure, for real this time. So I'll be back in a couple minutes. I'm gonna go upstairs and grab a set of calipers and get a drink of water, and I'll be back in a minute or two because I know exactly where the calipers are. All right. I'm back. I have the two tips in question that I can't tell which is the genuine Hacko and which is not. And I have my eye gauging calipers. Not a sponsor, but I will go back and if they're still available, we'll update the YouTube description to put a link, as they've treated me well the past couple years. I don't know exactly how long I've had them, but they've treated me well. They do metric, they do imperial, I think they even do fractions. Yeah, they take a CR2032 battery, which is nice. Anyways, all right, so we got that, and I guess simultaneously, I need to pull up the Hacko USA website. It seems to make the most sense, I think. Which I will pull up on screen so you can see what I'm seeing as soon as I get through all of the pop-ups and everything. And I guess I should probably allow cookies, but okay, so I think these are T15 tips. No, these are not T15. Wrong. These are T18 tips. I get some of their, because I've used the ones we have at work take T15s. All right, and I can tell if I can sort by well, now I see a candidate right here. The this T18B conical tip, for example, that might actually be what this is. That model number seems familiar. I could probably go back in my emails and find where I bought the tips. But anyways, the important measurements that we need are the length of the business end of the tip and the diameter of the tip itself. That looks like the two pieces that will give us what we need to know. So let's get those two measurements, and then we'll scroll through the list of conical tips and see if any of them match. Now, it's going to be a bit interesting getting these dimensions, but all right, so this tip looks like it's about 13.5 millimeters, and I know this probably isn't really the best way to measure this, but so this is about 13.5 millimeters, and the diameter of the tip is about 1.3 millimeter. Okay, and this one here is about 1.5 millimeters, and it looks like it's about 12.6. All right, so hopefully I can remember numbers enough to come over here. Okay, so that one's not it because both tips are too short. Let's keep scrolling. Let me move my mouse to the correct monitor so I can actually scroll. Okay, it's not a bevel tip. No, it's not a bevel tip. It's not a chisel tip. Conical sharp tip. No, I don't think that's it. Not a bevel tip. Oh. Is maybe... I mean, pictorially, that kind of looks the same. I mean, maybe... Well, I mean, maybe I'm not measuring the... Because I'm looking. There... Here I am doing a pretty good job of... You know, if I was going off the shape... You know, I think I figured out which one's the genuine Hacko. Just based on that line diagram there. All right. Let me pull up the, let me get the microscope here. A little subtle. It's subtle enough that I think I overlooked it without actually having the diagram in front of me. All right, so you notice how this tip, it just kind of, the chisel tip just abruptly ends. Well, take a look at this tip. You know, it's probably good that yeah, T18B. I didn't even see that. I couldn't see that without a light shining on it. Even though I did try to look at these. Anyways, I couldn't see that text without this microscope. But anyways, you see how this kind of, there's an angle? Yeah, that matches the illustration. Of course, that's how good of a knockoff these other tips were. I had trouble seeing that. I should have known that Hacko would have engraved their tips because of all of the knockoffs. And indeed, right there, that appears to be, quite honestly, that's probably a serial number. Hacko lead-free, made in Japan. I mean, these are the good tips. And if someone from Hacko USA is watching, wherever watches this, I'm sorry for buying the cheapo tips on Amazon. I've learned my lesson. And next time, if I do manage to get the genuine thing mixed up, I'll just remember it. You actually, yeah, I'm looking at, yeah, I did not even notice that text. Now that I know the text is there, I know to look for it. I didn't realize they were engraved. So I got all these tips mixed up. And then on stream on Monday, I think it was Monday or last night, at one point, I tried to, as a last ditch effort, go back to what I thought was the genuine Hacko tip. And I think now that I look at this tip, if you look at how it's discolored from heating up, actually under the microscope, now I really could see the difference in quality. Anyways, so this is, so I now know that if I want to buy tips to try, I might as well just buy the Hacko tip I think I want. I wasn't sure which would work well. Now I think I know that the generic ones don't work well. But anyways, see how nice and smooth. Now, part of this might be because I've not used this tip. See how that looks fairly smooth? Now look at how under magnification that just looks awful. And I mean, I don't even know what metal this is on the inside. I don't know. I mean, I thought that these were, well, sorry. Oh, it would help if I mean, I don't even know what metal that might be. I don't know if that's copper like the Amazon listing claims, or I mean, it looks pinkish, but I don't know. It looks like it's plated on the inside. I mean, and it very well may be plated on the inside to disguise whatever metal it is. I mean, this may not be copper. Anyways, so here's another. I tried to use this tip too. I didn't use it. That much, but yeah. I think now that I look at these under magnification, they're really kind of rough. Anyways, now that I found the genuine Hacko tip, and go back to that because that's pretty smooth, and that's the factory tinning. That looks pretty nice. Now that I've found the genuine Hacko tip, next time I feel like soldering, I'm gonna try this tip, and it probably will work really well. It will probably just work. I won't have to worry that my Hacko station is the temperature's not correct. Unlike with the generic tips here that I tried to use, quite honestly, I think some of my trouble may very well have been them. In fact, in earlier streams, I was mentioning that I had the part for these generic tips in the YouTube description. If you look at tonight's YouTube description, and in fact, I think I might have even Monday night stream, I think I even pulled them off of it. But yeah, I no longer have their part number on the YouTube description because I can't recommend them. And that's partially because I had so much trouble using them. And I'm not totally for sure that some of my troubles weren't just how fantastically awful they are. And in fact, my coworker that does soldering a lot did admit to me that, yeah, those Hacko clones can be hit or miss, and apparently the ones I got are a miss, as in A space MISS, although the word amiss, AMISS, would also be appropriate. So anyways, now that I have found my genuine Hacko tip that goes in my genuine Hacko soldering iron, it belongs to my genuine Hacko FX888D soldering station, for which I do know there is a link in the YouTube description for the soldering station. It is probably their #1 selling solder station, and I can definitely recommend it. And maybe, now that I have the genuine Hacko tip, this lead-free solder, I might actually be able to get to cooperate. Maybe. We'll see. I mean, this Custer usually makes good solder, so I'm hoping I can get it to work, and that's interesting. This is lead-free solder. This product contains traces of lead. Lead-free rosin core solder. Contains traces of lead. Huh, weird. Well, I don't know. That's really weird. Anyways, so if you'd like to see the Zoxbox build continued, I do know I'm going to have to order some parts, apparently, because although it does look like some of the parts I thought I had used on the other board, I'd already reordered more of, because I just realized there's the capacitors. I must have reordered them at some point. So follow me on Twitch, subscribe on YouTube, ring the bell icon, like, dislike, constructive criticism in the comments, or just say hi. Tell a friend. All those good YouTube-y things, or Twitch things. And then next time when I go live, which will be tomorrow night, weather permitting, I'll probably be looking at Mac stuff, and then Sunday afternoon, Solder Sunday, assuming that I have the parts to do it. Actually, that's right. I actually have a Learn to Solder kit that I'm going to take a look at, even though I know how to learn solder. One of my coworkers gave it to me, partially because he wanted an assembled example for others to look at, and I guess he thought that I would be a good person to go through a Learn to Solder kit. So, I mean, I'm probably still learning, so that might be what I look at Solder Sunday, is that Learn to Solder kit. I'm fairly sure that it's hopefully simple enough that I won't screw it up too bad. But I guess worst comes to worst. Well, after all, I found my genuine Hacko tip. I don't think my order from Hacko USA will be in until next week, because I think it shipped from California. But I think for Solder Sunday, we'll look at that Learn to Solder kit. That might be pretty fun. I think it makes noises. So the Zoxbox will probably come back for Music Monday. If I, probably in the meantime, I'll be checking to make sure I have all the parts I need. And if not, I'll try to order them. I'm sure I can get some parts. I know some of these Nichicon capacitors I ordered have been discontinued. I may have to find equivalents. These are like audio grade capacitors. So I may have to find some substitutes in some cases, but I will get back to this build, and it is going to be done well before I have grandkids. Mark my words. I'm hoping to actually get it done sometime this year, because I've had it for long enough as it is. I want to hear this thing make whatever noises the Roland TB-303 made sometime before the century is out. Not because it is easy, but because it is hard. And with that, it is getting late because I am rambling on. I should probably bid you adieu. Have a great evening. And I hope to see you in a future stream.